by using only a calculator. No, in earlier times, no, uh, big structures are already constructed, and then the computer is not yet around. So, and even calculator is not yet around. So it's really very difficult, very challenging for anyone to pick up engineering degree at the time. No calculator, so multiplication of big number is a challenge. How much more is the division? And then the formula of engineering always requires square root. So solving a square root is already a headache. Not mentioning the trigonometric functions. No? So when you are going to look for the sign of, let us say, 15.75 degrees, that's already a headache. No? So it will take you another 30 minutes just to look for the sign. And then once you got the a very long number of the sign, you will be able to multiply it to a certain number. Then how can you multiply accurately with such long decimal places is uh, is an ability, no? So you must be mathematics lover, no? If you take up engineering in those days, no? Because calculator you are using slide rule, no electronic calculator, no computer. So and still during the time uh, tall buildings in New York and Chicago is somewhat already in existence. So structural analysis and design in that in those times is very challenging. But those days are already one uh, are already in the past. No, we are now in the modern era wherein uh, computational wise we are somewhat lucky because we have those tools. No, we have computers, we have software, we have everything. Okay. So the only thing that we are going to handle is the board exam because the board exam does not allow the use of computers. So like that. So that is the topic I'm going to discuss this morning is the three moment equation. Okay. And yes, three moment equation. Okay. So this one is somewhat easier to use, no? Because if you understand only how the three moment equation works, you can analyze continuous beam uh, faster. But it doesn't mean that you only have to know this method. Besides, you know already the consistent deformation method. No? And then there are really a lot of methods. This is the second method of first method that I am discussing for solution of statically indeterminate structures. Okay, so I will proceed. Uh, there's a document that I am going to picture. No? So this is the three moment equation. No? So here in the figure you have a simple beam, no, of variable loading. So now as we see, simple beam lang is yan, no? Simple beam with support at both ends to make it simple. Now, the beam we are considering here is this solid bar, horizontal bar. And above it is the loading, no? And it is labeled there as any loading. Now, to give uh, to make what we call this points within the beam, we assume points 1, 2, 3 as arbitrary points within the beam. So since it is any point, so we just put it anywhere, no? In in order, no? You have one, two, three. Okay. So we assume that this point could be a joint, no? A joint. But for the time being, we just consider it as a point in this beam. Okay. We also estimated the depleted structure due to this type of loading, no? So So in the figure, you have the beam, you have the support, the loading, and the depleted structure, and the arbitrary points inside the within the beam, points one, two, three. Okay, under points one, two, three, you drop a vertical line. So this point one, two, three, due to the load, will deflect. No, so there is a point there under points one, two, three in the undeflected shape. So the distance traveled by point one to the elastic curve is what we call as the deformation of point one or the vertical deflection of point one. Okay, and the distance traveled by point two in the undeformed shape going down to the elastic curve is what we call the deflection of point two. And so the other one is the depiction of point 3. Okay. Now we let each one L1, L2 as the vertical distance from 1 to 2 is the vertical distance from 2 to 3 or 3 to 2. Okay. So it's clear from this illustration. And yeah, there is length. So L1, L sub 1, there's a subscript 1 and 2. No? So L sub 1 refers to the distance between points 1 and 2, while L subscript 2 is the distance between points 2 to 3. Okay. Now, if we are going to segregate this, no? If we are going to segregate, what is it? We are going to segregate this. Okay. Format. If we are going to segregate that, okay. If we are going to segregate this, so this is the one, no? And since we cut it at point one and two, so there is a moment here, no? Represented by this curved arrow, okay? The direction is going clockwise. While at point two, on this point, a curved arrow there in counterclockwise rotation represents in two. So there is a subscript two that represents that it is at point two. And also V1 and V2 are the shear at 1 and point 2. Similarly, on the other side, moving here, this is the second uh, substructure. Okay, so we have L2 and then we have also M2 in opposite direction as that one and also M3 at point 3. Okay, then from this, okay, taking this free body diagrams, so we have free body diagrams of segment 1, we call this segment 1, this one as segment 1. Okay, that is segment 1. So if this is segment 1, if that is segment 1, so if you have a load there, actually that is just any loading. So we do not know what shape of the moment diagram will be. No, it depends on the load. No, so the shape of the moment diagram is just assumed to be like this. No, like this. Although since we do not know what kind of load, whether it is a concentrated load, a uniformly distributed load, so we do not know. No, that is just any loading because in actual structure that we will be solving, it depends on the given load or the load that we are going to assume to be carried by the structure. Okay. because not all loads are given, no? Especially if you are practicing already, you say, I am going to design this beam, but what is the loading? So you can only refer to book as reference, but when it comes to the magnitude of loading, you will be the one to analyze. Now, based on the uh, code of the place, no? Say, pala, mga sa country na ano sa mga code, so doon na sa mga gitawag na to minimum load. Okay? So this is the resulting moment diagram, and then these are what we call the moment diagrams of loading by end moments. No, basically we convert this load into a different form of moment, equivalent moment. No, but you have to use end moments. No, okay. So this one is the resulting moment diagram of any load. So this is just a representation, and this one is just a representation. Okay. These are the end moments, M1 and M2. And these are the unknown. These are the unknown that we are going to solve. This one, basically this one can be solved. This will be based on the loading above. Now, sa ikaduha nga structure, kini gitawag nato free body diagram 2. I call this 2 because this is 1. Gi-isolate siya, so muna ni siya, no? Muna siya ang iyang kuan. So, wala namang ipakita ang uban para dili siya mo complicate. This is the assumed building moment, no? I say assume because it will depend on the loading here. Okay, it will become a parabolic if this is a uniformly distributed load. It could be bilinear if you have a concentrated load here. But since we do not know, we just represent it as like this. Okay, and this one are the end moments into and into. These are the unknowns. These are the unknowns of your third moment equation. Okay. So let us view the elastic curve of this one and 2. No, so this is 1 and 2. Okay. So 1, 2, 3. So this is 1, 2, 3. 1, 2, 3 here. Then we do the tangent lines, the tangential deviation. So basically the three moment equation is just paano siya gikuha ni siya sa katong area moment method. No, why? Because there is tangential deviation here. So you do tangential line. No, so this is basically the compatibility equation, the compatibility figure, and you can determine compatibility equations here. No, such as well, you know that this one is H1, the difference between 1 and 2. So it is repeated here as 1 and 2. But each one is composed of tangential deviation from 1 to 2. Okay. Tangential deviation is the second theorem of area moment method. No, tangential deviation, like the definition of 1 and 2. No, if I'm going to recall, T12 is equal to the area of the NEI diagram under points 1, 2 times x1. x1 is the distance of the centroid of your NEI diagram with respect to point 1. Okay. And then, so this one can be determined if you know h1 and you know that, so the rest can be determined. How to determine that? This is just the difference between h1 and t12. So that's why it's what we call h1 minus t12. Okay. On the other side, the same thing, no? This one can be determined, no problem, it can be determined. It's just a matter of how. Okay, so we call this as H3, and then we do a tangent line, so we can determine this distance from this from the point of tangent line under point 3 to point 3 as T3 plus 2. No? This T3 plus 2 is what we call as the tangential deviation of points 2 to 3 with respect to point 3. And it is mathematically defined as the area of your NEI diagram under points 2 to 3 multiplied by the distance from the centroid of your NEI diagram with respect to 3. Okay. Once you know already that, the other one can be determined, no? So it becomes the T32 minus H3. Okay. So like that. So that is the way of the three-moment equation. Okay. Now the three-moment equation then this one is just a derivation. No, I will not go to this. I will just give you the formula. No, so the formula. So I'd rather go to the bottom. Yeah, this one. This one is the equation of your three-moment equation and after very lengthy derivation. No? I am not going to discuss derivation in online, no? So it will be very difficult, no? But this is taken from this figure, no? From this figure, okay? So well, this equation are just taken from this compatibility equation. Okay. So this is now what we call. This is now what how what I mentioned a while ago that it came from the what they call this area moment method. Okay, area moment method. So basically, the M1 and M2 are just assumed no, to exist, but they are really the unknowns in your equation. Okay, so much of the equation we proceed directly uh, to the fish fillet, no? Kaya kung siya tanan isda ba man siya, no? At least kaya doon na pa na siya yung mga tunai, doon na pa na siya yung mga hasang, na pa na yung mga bukog, na pa na yung silip, na pa na yung ikog. So, ayo siya, no? So, until na naka-fish fillet na magamit, no? So, this is the equation that we can use. Okay? So, I'm just using analogy, no? So, basically as the final equation, no? Meaning, it can easily be used. Okay. So, we have M1, L1, 2M2, L1, L2, M3, L2. Now, in the problem, M1, M2, and M3 are the unknown. That's why it is called three-moment equations. L1, L2 is given. Okay. Given in the problem. Of course, when you try to solve a problem, the length of the beams are given. No? For example, you have a two-span continuous beam. So the length 1 and the length 2 are given. And also the load is given. Okay. Since our objective is to analyze the beam, so therefore we want to determine M1, M2, M3. Okay. M1 refers to the moment at point 1. So whatever point 1 there, if you wish not to use number, you use letter, so that could be MA, LA, MB, MC, like that. You can use letter, but here we just use numeric. Okay. How about area 1 and area 1? Area 1 is what we call as the area of your moment diagram. No? Assuming that they are simply supported. Also for your A2, the area diagram of the moment area of the moment diagram of it BD2. So that is to distinguish 1 and 2. So why there is subscript 1 and 2? Remember we have two substructure here. You have substructure 1, substructure 2. So anything related to substructure 1 have a subscript of 1. Okay. Okay, like L1, area 1. So this is the area 1, area of your moment diagram. And A1. A1 is the distance of kanamo kung length niya L1 is divided into two, A and B. So A being the okay. What is the boundary of E1 and B1 is the centroid. Okay. Once you find the centroid, saglit din saya centroid. Anybody? Binisaya sa centroid. Wala ang kabalo. Okay. So, kada moment diagram, doon na siya centroid. No? Centroid. Now, ang total length ana niya from the initial point to the end point is what we call L1. Now, that L1 is divided into A and B. The boundary is the centroid. So, the subscript 1, just refer that it belongs to the first figure, okay? The left free body. As for the right free body, it's the same thing. You have the moment diagram, and then you are referring to the second free body diagram. So, the area of this figure is called A sub 2. The 2 there refers to the second figure, second free body. And the length from the initial to the terminal point of the beam is called L sub 2. Again, there is a subscript 2. And there is also a centroid of the diagram, and that's the boundary of E2 and B2. No? The sum of E2 and B2 equals to L2. Okay, so that's it. So that is what we call E1. No? So this is the formula we are going to use. Okay. Now, there is an example to this, no? So let us say this one. Okay. First, we will discuss what is capital A sub 1, small a sub 1, and B sub 1. No? So it depends on the type of loading. It depends on the type of loading. So let me discuss it to you. Okay. If the loading is this, no? The loading is this. And this is A and B. Okay. So this is the value of your 6 times A over L. Okay. Because you need this from the equation, no? This one. Okay. And you need also this one. So there are three columns. The first column represents to the load case, the type of loading you have. So there you can determine what is the L and the A and the B, no? A and B. Okay, so the 6A over L is equal to this. And the 6EB is equal to this. If the load is at the center, this will be the value of your 6AAL, and this one is for the other column. So for this one, the value of your 6A and over L is equal to WL cube over 4. So it's like that. So I have here several cases, no? Several cases. Okay, but not much of not some of these are seldom used. What is usually used are this type of loading. Okay. Sometimes I give this in the problem. Okay. Okay, sabi ko one. Okay, so this is the three-moment equation class. So we just use this equation, and it's easier to use, no? It's easier to use. Okay, so we solve a certain problem. I have an example here. So I have an example here. Let us say this one, this example, no? This example. Okay. I am going to. Okay. Okay. So this is the example one. Now, if you are going to analyze, if you are going to determine what is the degree of indeterminacy here, this is indeterminate to the first degree. Okay? Okay, indeterminate to the first degree. Okay? So R1, R2, R3, we do not know. We don't, so this time we cannot solve this using equilibrium. That is why we have to apply compatibility, no? Or either we use consistent deformation, but this morning we will solve it by using the three-moment equation. So the three-moment equation is bangko na to siya nga method, no? Of solving this. So what I discussed a while ago is just simply a derivation and the discussion of the variable used in the equation and uh, how it will be used. Okay, so we'd rather use this equation. Okay, this is the equation that we are going to use. No, I will cut this. Okay, I will cut that. And then okay. Okay. So sa ano yung nga problem, mo na akong gamiton yung equation. Okay? So I will divide this one, no? So I will divide this one. This one can be divided into two. Perfect kasi siya nga two, what do you call this, two free body diagram, no? One free body diagram has a length of 4, while the other one has also 4, no? So, pwede na muna siya yung noun. Then, if this is 1, this will be the moment at 1, this will be the moment at 2, okay, for the first figure, and then for the second figure, this is moment 2, and this is moment 3, okay? So, but we know already that moment on the left support is 0 because this is pin or hinge, and also the moment at point 3 is 0 because this is supported by hinge. So we are only unknown is the moment at point 2. Okay, so we let point 1 as the left extreme left end and moment and point 3 for the extreme right end, and then point 2 where the reactions, the middle support is located, and the load is this, no? Basically, if I am going to do the depicted structure, the depicted structure will look like this. Okay, will look like this. Which one is heavier? Okay, so it would look like that. Would look like that. That is how I analyze it. Okay, so this is the solution, no? So okay, this is the equation. Okay, so bali ang unang equation ani ako ning kopyahan na. Ako ning adto sa ako ning kopyahon home copy. Bali kung ako na siyang analyze on base adtong kuan. Ano na ano. Okay, so I am going to copy this. Okay. So, mo ni siya ang imong segment 1. Segment 1. Segment 1. There will be two segment, no? So, isa segment 2. Okay. Mo ni siya akong ipakita din. Segment 1 at segment 2. Or free body 1 or free body 2. Okay. So, this is segment 1. Okay. I will, okay, that is segment 1. So, in that case, I can insert here as this back. So, this is point 1. Okay, that is point 1. But I will not, I will Okay, sa mga experience, ha? 9, this box. Okay. So, here, you can have in 1. So, this is 1. Muna siyang 1. Yan din mo ni atong gitawag og 2. Insert mo ni atong gitawag og 2 din. Yan siyang point 2. Okay, muna siyang point 2 diya. Okay. Okay. So, going back, mo na siyang point 2. So, this is R1. Unya din doon na sa kay gitawag na biting kuan moment, no? Na may moment sa figure. Okay, wala kay moment diha. Ato na sumpayan online. Pangit kayo. Kasi na lang, may na kaysa wala. Okay, ako mo. Ngayon mas kasulat, no? Okay, isa. Ito na. Ako na siya i-group. Group. Ako na siya. Copy. Paste. Yeah, tuloy na siya. I-click. Click. Okay. Ako na siya i-move din na. Okay. So, din sa Pikas, ang ngalan niya na kay naman siya sa point 1, tawag na to siya o M1. M1. So, subscript na siya. Subscript na siya. Nato ni siyang kopyahon. Copy. Paste. So, masih tulong na to into. Okay. So, mo na siya, no? Yeah, so segment 2. So, M1, mo na siya diha. M2, mo na siya diha. Yeah, ang L1 niya is 4. So, basically, butangan ni mo nag-figure karon kung ano. So, sa segment 2, mao ni siya segment 2. Ato niya reason din. Comment pa. Mao ni siya ang pagbuo sa segment 2. Okay. Ito. Mao na siya ang segment 2. Okay? Ato na siya tulod sa sulat. Luyo, no? Tulod sa dito. Okay. Space. Okay. So, kini siya mao ni M1. Ito. Kini siya sa segment 2. Okay, gawas pa din niya. Muna siyang itawag og L1, no? L1. Ang L2 mo, equal sila, no? So, din hinagya po ni siya. Copy. Paste. Yeah, kini siya din copy. Paste. Is 2 na ni siya dito. Hindi siya point 2. Macam point 2. Hindi siya point 2. Yan po siya. Yeah, kini siya din point 3. Point 3. Now, in point 2, so, point 2 na siya din. Hindi din tawag natin siya o point 3. Kaya, point 3 man, so ito siya. So, pero before you start using this equation, tanawon sa nimo say you also minimize the number of unknowns. Why? Because there are certain points that you know already the moment. Okay, so like for example, if I'm going to look at this, if I'm going to look at this, the moment at the start and at the end is zero. Okay, at the start or at the left support or at the right support is zero. Again, why is it zero? Because it is supported by pin and roller. Okay, and the middle is not zero because it's not zero because although this is made up of pin, but this is continuous. No, it's continuous. Okay, so it will hold like it will hold moment. So here there are things that we know. No, things that we know. Things or can we talk about the of things. So ato na to inyo nga na kuan predetermined uh predetermined uh moments, no moment called it variables such as m1 that is equal to 0, m2 is also equal to 0, l1 is equal to 4 meters, l2 is equal to 4 meters. So those are the things that we know. But this one is a subscript. 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 Okay. So if we use this into our equation, then substituting substituting into the three moment equation, I think it's only one. We have the first we have m1. We have 0 times 4 plus what's this? Hello, Doc? Ah. Wala mo dyan tawag. Huwag na mag-ipalo mo ang sipon. Wala pa, hindi siya. Pasti na kita sa tunay. Ito eh. Ano ba? Kumana naman lang isip yun. Relax naman. Relax naman lang isip ko. Walang workshop. So, isisend lang. Yan, kung gano'n daan ako panalas na. Oo. Oh, kung may mo, apa tayo sa division niya kay isang na perspective ba? Division sa ba? Oo. Sige lang, hindi mo matter, 1 meter. Sige dyan, okay. Okay, so you have 0 times 4, 8 times 2. 2 into. Then we have a quantity there. Quantity L1 plus L2. So you have 8. Okay, this one is a subscript. Sigma laan na ito ng multiplier. Then we have another plus. Plus entry is 0. 0 times 4, then plus again, 6E1, 6E1, E1 divided by, what's that? 4 plus 6 B2, B2, B2 over 4 must be equal to 0. Okay? Now, the first one is for the first segment, you have a load like this. Now, we are going to look the value for 6E1 L1 for this, no? For this figure. Okay? So, I am going to move forward there and look for the type of loading. So this one, no? This one. But this one is from maximum to minimum. So, kung tanawan mo ang loading na ito din, baliktad. Baliktad. So that we can use this, ato ni siyang balihon. Balihon niyo muna siya, kung anion niyo muna siya, I will cut that, no? I will cut this. I will cut this. Okay? I will cut, how I will cut, control screen. And I will cut that here. New. And save paste. So I will cut this. Cut. Ay, save. Lagi, cut lagi. Cut na po. Then I'll go back to the word. Okay. So, magamit ko na ako. Ako na siyang i-paste din. Okay. Paste na ko na siya. Ako na siyang i-flip. I-flip na ko na siya. So itong flip. Rotate. So, may na siya. Balik tayo sa na ko na siya. So, ang isa, 7 ko ano siya. Ang edinhi, ibaliktad na ko ni siya. Hindi siya baliktad. Butang ko lang. Cut. Paste. Ano ko na butang. Yeah. Okay. So, may anin siya. Okay. So, muna siya ang kanilang lang. Yeah. Okay. So, yung anak, no, instead nga 7 mag-una, just like this, baylo na ko na siya, gi-flip, no, gi-flip ko sa nako ang figure. So, yung anak. So, this will be the value of your 6AL, no? So, 6AL. So, we rather use this equation, no? Yeah, this equation. So, from here, the equation of 6, this one, A1. 6, is over 4 is equal to hello. Oh, good morning. Good morning, sir. Tiffany. Hello, Tiffany. Hi, good morning, sir. Good morning, architect. Ikaw po yung isulit ako ni Engineer Tulod, no? Yes, sir. Okay, sige, sir. Wala yung problema, sir. Ah, yes, yes. Okay, okay. Mm-hmm. Yeah, wag pa na sila, sir. Kanang pamilya nga apelido na, sir. Ah, mm, mm. Okay, yeah. Ikaw ang architect. Mm. Yes, yes. Lagi, lagi. Ah, sige, sir. Sige, sir. Wala problema, sir. Magpunta. Before we start, i-review lang. So, ako, sir, itong sa taon ni. Ano, kaya, sige, sir. Okay po. Actually, tama niya po yung mga existing na mga pag lugar mo na siya. Especially nga nakakagig dyan. Uh, pila ba ka square meter sa development? Wala pa kayo kuhan, side din? Hmm. Hmm. Ah, sige. Maghatag na lang ko siya, per square meter ko lang siya, kay, like other, for me, other professional, they will just resort to per square meter. Yan na. Actually, ako, the research medyo sa payo mo 70 per square meter. Oo. Oo. Actually, wow mo gina akong gano'n siguro, kung usually, tanong lang to kung sa 60, 60 na lang. Ato at mm, 50 pesos sila. Ah, ah, sige sir, para kuhan, at para sa yana ka na. Wala problema sir, no problem. I will pa. Ako i-add para sir. Hmm. Email lang kung gamiton sir. Sige sir, I will send you my email. Mm. Sige sir. Mm. Actually, pag ma, sana kay deal, we can start one, as soon as possible. The structure. Oh, Tanawon sa nako ang plans eh. Tanawon sa nako ang plans. Yan, schematics. So. Ah, permits? For permits. I can, akong kuan is I can supply you the structural plans and calculation. The calculation. Oh. Okay, mo man ang kinalan sa Office of the Building Official from the structural engineer. There is architectural and then kuan. So, I think usually the happen is I will supply the structural plans. And then for further purposes, we ask for a structural calculation. So, that's already fun. Included. Yan na, ako yung nabuhat niya. Ako yung nabuhat niya ng mata. Paano na dasal ng slooping kayo? Pero, ang yuta, di man kayo, kay, ang yuta is, belongs to, kailan, there is deposit. So, which is, basically, okay siya. Flat rate yan. So, doon na kay contour, sir, sa Gatnan. Okay. Na-supply mo na sa supply mo sa mga hindi ka na, hindi ka tubo na mga ganyan. Actually, sir, sa mga dagpo na mga project, discovery na siya, no? Alam, require na siya, sir, kay, if daghan mga clients na ako, abi nila o require kay kuan lang. So, they require for more than 2 stories. Kaya para sa mga long span ng mga building, umabot tag 50 meters and above. Yan. So, I think na yung 3 story, exceed na siya. Sa kuan. May mga local din ng mga kuan, ng mga kuan, mga geotech na firm. Ako lang na kuan sila mo charge sila 4,000 to 5,000 per meter. So, gamay naman din, pwede story, pwede naman natin tatawag ka ng 6 meter. Mabuhulan ng 6 meter. Sige sir, sama na ang Zoom meeting sir, schedule na siya. Kuan lang. Tama. Sige sir. Yan na. Lagi. Okay lang sa okay lang sa sir may pandemic sir kay we can meet in time ba face to face. Yan ko. Pero sa awan man nga boost ako din mo man. Yan lagi lang. Wala may problema din sa video sir. Kasi matiyang to be part. Iba yung LDO at its own protocol, so you have to follow. So, normally, kung wala kayo gawasan, sige gawas. Pero, magkagawas nyo magkagawa niyo. Magka-field visit niyo. Sige sir, thank you sir ha. I'll send you my email to this for this sige. Yes sir. Thank you. Okay, so thank you. Okay. Thank you, Mike. Thank you. Okay, class. Sorry. So we need also this one. Okay, and we have to paste it here. Okay. So for this one, uh, the formula is 8WOL3 over 60. That's for the over L na siya, no? Over L. So this is for over L. Over L ni siya. Over L. Okay, so this one is over L. So A1 is 8WOL cubed. 8WO 1400, and we have 4 raised to the power of 3 divided by 60. Over 60, this is the power of 3. So we have 4 times 4 times 4 times 1400 times 8 divided by 60. So we have 14,933 and 333. For 6E2 B2, we need the area of 2. That is the one. Actually, this is the solution class. Okay. So, 1,200 side mo na akong calculation. 4 times 4 times 4 times 8 times 2,200 divided by 60. Sakto na. Sakto ni. This is 1194, 6.67. For the second figure, actually, the 6E2B2 comprise of two terms. The first term is due to the concentrated load, and this one for the partially loaded. I think they are here. This one, no, you can use this one for just let's see equal to 0. You can use this one. So you can use this case and this case to solve for 6E2 6E2 times I think A1. No? B2, no? So, you can use this equation and that equation. Why there are two equations? Because you use the superposition method of two cases. The first case is this one, and the second case is this one. Okay? So you just substitute the value of P, value of B, L, W, and you get your 6A to D2. And substitute that to your equation. And you get into equals to 139.98. Okay? So that means that your moment diagram, moment diagram is equal to this. The moment diagram and shape and just do the moment diagram color. Yeah. And then label this as 1, 1, plus 2, this is 2. Okay. Due to the loading, it is like this. There's moment here. Moment here is the moment here is into equals to minus 1391.28 Newton meter. Okay, this one is a subscript. And the moment of first segment is this one. No? Okay, that's the moment. No, that's due to this load. No, and then the moment also of the other one is like this. Actually, may I see this? I do not know if it's. I don't know if it's like this. That's it. So yeah, we have a line here. We have a line here. And a line there. We have a line here. The two lines. And then we have here, that. And then we have this one. Okay. So that is the shape of your moment diagram. So M1 is 0 and M2 is 0. No? Now, if you want to solve further, you can use the moment diagram here to use for the shear diagram, which will look like this. No, the shear diagram. This is just an estimated shear diagram. Diagonal na to. Boom. Okay. This. Yeah. There. So this is my 21. 22. This is my 23. 21. Then due to that, there is an upward. Then there is a downward here. Downward. And the diagram looks like this. This is only an estimated this time. Yes. That's because of this load. And then this one goes farther up, goes farther there. Then might be this is just an assumption there. Then you have a load here. Home copy, paste. There is a concentrated load here. Like this there. Then there's a gap. Yeah, there's a gap somewhere here. Then there's moment. So your shear diagram must look like this, no? Look like this. So this one could be a zero. That's not zero. It could look like that one's is that will be for the moment like this. Okay. Okay. So like that. So there are possibilities if no, but you have really to solve this, no? So by just summing up moment using equilibrium because you know into already, no? You know into already. So as of this moment, class, I use three-moment equation to analyze this problem. So I just up to the moment diagram because three-moment equation will give you right away the moment. Now to solve for the reaction, you still have to solve it using equilibrium. Okay, but that's not a problem anymore because you solve already into. Okay, into. So using this equation and then what is new here is just determination of the last two terms. But to determine the last two terms, you just use this diagram. And you have to be innovative on how to use it because not all cases fit directly to this, no? So just like what we did with this one, we just click this or we just click also this value, okay? In order that we will have this. And also the use of this, you can extend the value up to the other side if you let C equal to 0. Okay. You can also make this into a case like this. Uh, by letting A and C equal to 0 in the equation. Okay. So this one is more general actually. This is a general. Okay. So that's why when we solve for this one, nasa two terms because the first term caters for this one and the second term caters for this type of loading. So basically it uses the superposition of the two load cases. Then you have that so then you have the into. Now I give you into. Now it's time for solving the shear. Okay. So this is just what we call this estimated shear diagram, no? Based on the load. So that's it, no? Uh, I will stop now because I have class, no? Okay, I will save this. Okay. So class